We live in a time of information and data. We are in the age of machines and the Internet of Things. We rely on them to provide communication, transportation, fabrication, and all matter of automation for us in our personal and business lives. Regardless of how autonomous these machines become, they require management and sustainment from people. This is relatively straightforward when a machine is well understood and support is basic. Think of your own car. However, large organizations employ vast fleets of equipment of many types. Acquisition, operation, maintenance, and supply functions are fulfilled by different divisions within the organization. Each functional division uses terms and information systems suited to their particular roles. Each division is dependent upon the other to provide relevant data. However, each functional area produces and expects to consume data in its own format. This creates a language barrier between the separate areas of the single enterprise, hindering efficient management of the equipment fleet. It's not enough to have the data. We must be able to find the data and understand the data. It must be semantically enabled. We must be able to decipher the syntax of another organization's system. We can then collate the data in order to derive context and meaning. Workarounds are commonly employed. One approach is to build point-to-point interfaces between information systems. These are complex and expensive. Each interface will require periodic maintenance when supported systems are upgraded or modified. Alternatively, organizations copy data into warehouses, or they employ data mining and cleansing techniques to support analysis to help direct big decisions. These techniques are costly, redundant, and ignore the impact of latency. At times, decisions are made without reference to the pertinent data due to the cost or time required for the effort. Coherent management of a large and diverse fleet demands common understanding of the factors that impact your equipment. You need access to your data across the various divisions. You need to be able to reuse that data to develop the information needed to make sound and timely decisions for the enterprise. The solution is to allow individual divisions within your organization to use the information systems and terminology suited to their roles in managing the equipment. At the same time, access to data from all sources must be provided in a format that can be used across the enterprise. Data are not objects to be copied, stored, and managed. They should be provided from the authoritative source as a service to support transactions and analyses as needed. This is called Data as a Service, or DaaS. Simply stated, the DaaS concept describes the sourcing, management, and delivery of data in a usable format. DaaS is built upon open, international standards and protocols for representing semantics of item data. DaaS provides a lightweight web technology that permits data resident in one system to be viewed, accessed, and linked by another. Data is managed and stored only by the application that owns the authoritative data. DaaS combines the rich data and activity models of international PLCS standards with the flexibility of the World Wide Web Consortium semantic web standards. This provides users a simple interface to conduct complex queries or transactions between multiple information systems in basic apps or web browsers. The DaaS solution is realized in the DaaS engine, which is composed of the DaaS provider and the DaaS registry. The provider allows access to the data. The registry identifies the source of the data, that is, where to look for them. The DaaS provider is divided into three software components: the interface, which allows the provider to get data from the source; the DaaS library allows the provider to understand the requests; the mapping transforms proprietary source data into standard structured data that can be read and understood. When the provider is deployed, the application seamlessly exposes standard structured data in the form of links through lightweight, maintainable, and scalable web services known as RESTful services. Those data can then be consumed by a requesting application. The DaaS registry is the brain that coordinates the providers. The registry answers 4 questions about the data: what's available, where is it, how is it accessed, how can it be integrated with other data. The DaaS registry does not retain any copy of the data. It merely acts in the manner of a library catalog, serving as a directory or index of data. So, let's look how DaaS might help mitigate the issues presented at the beginning of the discussion. The following simple scenario is used as illustration. The maintenance department performs scheduled tasks on an asset every 1,000 hours, based upon a maintenance plan directed by acquisition. Maintenance personnel pull current data from the operations system through the DaaS engine to identify items that will soon be due for scheduled service. They also request future plans for the asset to forecast usage and identify windows of opportunity for maintenance that will minimize disruption to operations. Maintenance also calls data from the BDAAS engine for parts needed from supply. Technical references to support maintenance may be requested from acquisition. Maintenance sends notification to operations that the tasks are due on an asset and pulls current configuration data through the BDAAS engine from their systems. When accounting pulls cost data about the item, they will see the labor cost from maintenance, the usage cost from operations, and the parts cost from supply. As shown in the simple example, data are exchanged through the BDAAS engine, which supports create, read, update, and delete operations. Data remains in its authoritative source while enabling access, reuse, and refinement by enterprise stakeholders. Due to the web-enabled standardized interfaces, BDAAS is adept at supporting dynamic organizations with complicated organizational structures. It is deployable to any device with a web browser. This provides flexible implementation through web apps, cloud services, or integration with existing client applications. In 2014, the U.S. Marine Corps performed an analysis of BDAAS to determine its suitability as a solution to challenges associated with data accessibility, interoperability, and increasing data storage. This study identified BDAAS as an affordable, proven, cutting-edge technology. Its cross-domain capabilities provide options to data accessibility, integration, and interoperability that are currently not available in the Marine Corps. BDAAS can provide you increased flexibility to manage your equipment across a complex enterprise. It permits you to operate the software and systems that best suit each functional area. It does so by leveraging non-proprietary standards for data exchange and semantic representation to maximize the discoverability and utility of data. BDAAS offers you the flexibility to employ any smart device. It can interface with any exposed system or data source on your network or on the web. BDAAS is rapidly adaptable to organizational changes and is extensible to support new organizational relationships. BDAAS provides your organization with better access to better data, usable by all. BDAAS empowers informed management of all your organization's assets.